Hello everybody, we're looking at example 4 here. Before we get to it, you will need this definition from chapter 5. It says the integral from a to x of f of t dt is just capital F of x plus c. If you recall, capital F of x is the antiderivative of f of x. Sorry, a little sloppy there. And then c is just some constant over here. This was, I showed you in the last video how this was attained. If you needed to review, please go ahead and check that out again. So all we're going to do is we're just going to modify this definition here. So the antiderivative of this is this guy here, right? So what happens then if I write the same basic format here, right? Put plus c, only instead I put f prime of t here. Well, if you remember, well, what is the antiderivative of the derivative? I mean, you just get the function, right? So what is the antiderivative of f prime? It is just f. And we're just going to call this, and because you basically just plug it in here, right? So we're just going to get f of t. Now don't confuse this here. This is not, I repeat, this is not equal to this here, okay? This is the first fundamental theorem, calculus, and it is not this one. It's not this, because notice, this is not the prime, and I'm taking the derivative of the function to get the other one. I'm plugging it in, basically, right? And this is not what it's saying here. It's saying that this is the antiderivative of the function, and you apply the second fundamental theorem. This is the first one, this is the second one here, right? So this is very different from this, from just plugging it in. What this is saying is if you take the antiderivative of the derivative, you get the function plus some other constant value here, right? So anyways, we're going to need this for example 4. So if you look at example 4, it says here, find the solution to the differential equation f prime of x equals e to the negative x squared, for which f of 7 equals 3. And this is a differential equation because it is some y prime, right? It's either f prime or y prime. It's a differential equation of order 1. And then they gave us an initial value. So this is what we would call an initial value problem, because x was, so f of 7 equals 3, this means that x is 7 and y is 3. So we're going to go ahead and solve this now. And we're going to use this information that we have here, okay? So our goal is to, if you remember, it says find the solution here. Now I didn't say if we have a general or particular, but in this case we do have a particular, so which we're going to talk about why that's true. I don't want to write it down just yet. So we're going to plug in what we know here. So if you notice in the problem, they give you your prime equation, and we're going to write it as a function of t. If you remember in the equation, it's f prime of x equals e to the negative x squared. So this is going to be the integral from a to x of f prime of t dt equals f of x plus c. I just rewrote the whole thing. That wasn't very smart, was it? And then we just plug it in. So it's going to be the integral from a to x of e to the negative t squared, because that's the derivative of the function. It's just, I just switched the variables. I'm going to put dt equals some f of x plus c here, right? And remember, my goal is to solve or find the solution, right? And if you remember the solution here, when it says a solution to a differential equation, what I want is, let me write this out, the solution to a differential equation is some function. It's just a function. So you're either going to get an infinite number of functions, in which case it's a general solution, or a particular solution, in which case they give you an initial value. And since they gave us an initial value, that's what we're going to find here. And this, so the solution is going to be y equals something, which is the same thing as f of x. So we're basically going to solve, or we're going to find f of x here. That's what we're trying to find, okay? So I'm going to rewrite what I had here. I'm going to bring it down here for us. So we have the integral from a to x of e to the negative t squared dt equals f of x plus c here, okay? So now what we're going to do is we're just going to, remember, we need to find f of x, okay? And here's f of x, so I'm going to minus this c to both sides here. So we get integral from a to x of e to the negative x squared dt minus c equals f of x, okay? So you might be thinking like, okay, so that's cool. I don't know how this really helps me. But we don't know what this c is, and if you watch the last video, c could be positive or negative, so I'm just going to switch the signs and make it positive. Why can I do this? Because I don't know what c is. It can be a positive number, it can be a negative number, it doesn't really matter. So the sign of it is insignificant as well, since we don't know what value it is. So I'm just going to rewrite this here, and I'm going to put f of x in the front, because it makes me happy. And I'm going to put the integral, f of x equals the integral from a to x of e to the negative t squared dt. I'm going to put plus c1. Notice it's a different c, but it doesn't really matter. If I wanted to, I could have called it c. I'm just being consistent. So now what we're going to do here is we are going to figure out, and we're going to plug in our givens, right? If you remember, the givens in the problem was, so when x was 7, y was 3, right? So we know if we plug in, so when x is 7, the whole thing is going to be equal to 3, okay? So we're going to plug in a 7 in here for x, and we're going to plug it in here as well, and then we're going to set this whole thing equal to 3 when we're done with that, right? I haven't done it yet, so I'm not going to write it. So I'm going to get f of 7 equals the integral from a to 7 of e to the negative t squared dt plus c1 equals 3, okay? And now we have to think a little bit. We have to say, okay, so I want all of this stuff here to add to 3. So I want the area here, and plus this one here, plus this constant to be 3. And so you have to think, well, I'm going to think back to my properties of my integrals here, and I need to figure out a way to somehow make this thing simpler here. And, well, one thing we can do is we can say, well, hey, well, we need to find what this value of A could be, such that this could be true. Now, there might be more than one, who knows? But we need to figure out what it is. So there's actually a nice little trick here. So this is kind of a trick. It's kind of a logical trick here. You might trick if you want. We're going to let A be equal to 7. Okay? Why am I doing this? Okay, we're going to see over here. I'm going to take to the next sheet of paper. Okay? So if A is 7, look what happens here. So we're going to get, so f of 7 equals the integral. So now it's going to be from 7 to 7 of e to the negative t squared dt plus c1 equals 3. All right? So now we have an interesting thing here. Well, because this is the area from 7 to 7. Now, graphically, what that looks like is nothing, right? This is e, it's like some decay equation. If I'm going from 7 to 7, there's nothing. It's like there's no area there because I'm just stuck at a point. So this here is 0, right? So what we get then is, so that's 0, and we know that that's c1 equals 3, so therefore we can conclude if A was 7, right, then c1 equals 3. Or we're just going to call it c at the end of this thing, and then we're going to check to make sure that it satisfies this differential equation, or that our solution satisfies the differential equation as well. So let's put it all together. So remember we had here that the integral from a to x, so f of x was equal to this one of f prime of t dt plus c1, right? Let's plug in what we know, so f of x equals the integral from 7 to x of f prime of t dt plus 3, and if we want, we can go ahead and substitute in what f prime of t is, so f of x equals the integral from 7 to x of e to the negative t squared dt plus 3 here. So now remember, we know that it satisfies the initial condition that f of 7 equals 3. Why? Because if you plug in a 7 here, you know you're going to get 3 because the area from 7 to 7 is 0, and you just left with 3. So this one is satisfied. Also, we need to satisfy that the derivative of the function is actually e to the negative x squared. And if you take the derivative of this here, so I'm going to take the derivative of both sides, so I get d dx of f of x equals d dx of the integral from 7 to x of e to the negative t squared dt plus the derivative, because I'm distributing the derivative here to each thing, or to each term, excuse me, not thing. And what we get now, is you get f prime of x, right? Now remember, to be true, this has to be equal to e to the negative x squared equals the derivative of this, and now when we take the derivative of the integral of the function, we just get the original function, plugging it in. This is the first fundamental theorem of calculus, and now we're plugging it in because we have the derivative in front, e to the negative x squared. The derivative of a constant is 0, so actually this does satisfy the equation here. So my final answer to the solution, so this here, what we found, was my answer. So I'm going to write it out now that we have it. I'm going to do it over here. So in this case, the solution to this differential equation, this is a particular solution. I'm going to write, this is my particular. Why is it particular? Because I plugged in a value. So my particular solution is going to be f of x equals the integral, remember a was 7 to x of e to the negative t squared dt plus 3 here. All right. Now, that was the overall explanation for this problem here. Just if you want to know the quick-hand way, it's very simple. Look, whatever they give you for x, just put it on a, and whatever they give you for the y value, that's going to be your c, and then just plug in f prime here, and you'll get it every time. If you look at the solution, it's basically the same thing, but I wanted to show you where it came from, okay?